This is for Year 11 methods. It comes out of Chapter 17, 17D, question number 11. The path of a particle is defined by this equation. For x greater than 0, the units are in meters. The x is the horizontal and the y is the vertical. Okay, so there is the path. And if I have a quick little look at that path, this is the path that it follows. And if I wish to know the direction of motion, at this point here, I'd need to draw a tangent to find the direction, which means that I could describe its motion if I had if I knew that it was like this. At this point here, the direction of motion is governed by the tangent, and I'm going to describe the direction of motion by the angle that it makes with the x-axis, and that angle is going to equal the inverse tangent of the gradient. So, if I wish to find the direction of motion when x equals 1, what I would like to do is to take the derivative and set equal to 1. And then with that, I'd like to take the inverse tangent. So I might come up here and I might define this as being f of x. And if I take f of x and take its derivative, with respect to x, and then I'd like to make x equal 1. Okay, so the gradient is 7/3, and I'd then like to take the inverse tangent of the answer 7/3. And make sure I'm in degrees, and I'm in degrees. And that's 66.8 degrees is the first one. And secondly, when it's equal to a half, so I'm going to make x equal to a half. And that gives me an answer of 42.51 degrees. Okay. On the point of the particle where the pig is inclined at 45 degrees, well, I know the graph looks like this, and it's inclined at 45 degrees. If I go zoom and square it, it's a bit hard to tell 45 degrees because zoom squared has zoom previous. I don't have the same vertical and axis, so it's say 45 degrees. So what I want to do is the tan of 45 is 1, is set the derivative equal to 1. So if I take my derivative and I set it equal to 1, and I go interactive advanced solve, and solve for x, that will tell me the x values when the derivative is equal to 1. And since I have a restricted domain where x is bigger than 0, there's only one answer, and this is the answer. So find the point on the particle. So x equals root 13 on 3 minus 2/3. Find a point on the particle, so I probably need the y coordinate as well. And that will be take f of x and keyboard given x equals this. It can be simplified. and that's the y value, which is square root of 13 plus 16 all over 81. So that's the coordinate on the path. Are there any other points on the path which satisfy the situation described in part B? No, there aren't, because the only other time that the gradient's equal to one, and a gradient of 1, is outside the domain. So no.